the Welsh Crimson. Come on. All right. Let me get this up here. So on a compounded basis, which is pretty much the only way you should look at things, uh, if you picked a random month during these 97 and a half years, which is over 1,000 years, 1,000 months, 1,100 months actually, uh, on average, you would make 17 and a quarter percent if you invested only smallest 10% of the stocks. Remember, this is an implementable strategy. Okay. Of course, this strategy does not pay any commissions, and when it does the transactions, because every year you have to refresh this portfolio. When you do that, you don't cross any bid offer spreads. Obviously, bid offer spreads are typically much higher for smaller stocks compared to larger stocks. I mean, example, Microsoft stocks trades at $400, right? And bid offer spread on that is typically 1 or 2 cents. In $400, that's not much. But a smaller stock that trades at $5, that 1 cent actually is a big percentage difference. Okay. But let's look at the large stocks, the largest 10% of stocks. They only made historically only 11.6%. I mean, that ain't too shabby. I'll get you the numbers relatively shortly, but during that time, treasuries, I don't think even made 4%. Okay, inflation was definitely less than 4%. So there is still some real money made, 7 to 8% risk premium in a sense. But compared to small stocks, the so-called size premium historically is about what? Let's call that 12, 5 and a quarter, 575, almost uh, 600 basis points. That's a lot of money. And if we wanted to actually do a little charts, let's insert a chart. In fact, let me first put in the a risk measure. I'm going to calculate two of them. One of them standard deviation. And I'm going to pick all of these. You may have seen that it actually does something relatively funny to the formulas. When you do formulas with tables, that doesn't mean you cannot change into the standard reference, but this basically says go to table one, among the headers, uh, pick all the only data and use December or decile one as column name. And again, this is monthly standard deviation. I'm going to convert that into a regular number, because if I convert it into percent, that's going to be too big, right? So based on this, can you tell me which ones are riskier, at least in terms of total risk? Standard deviation is a measure of risk, not necessarily the measure of risk. So who's going to tell me among size-based portfolios, which portfolio is the least risky? Just look at the number. Yeah, decile 10. Okay, and those are the largest stocks. So in terms of risk, I mean, you should never use. Well, these are diversified portfolios. You could, but in general, don't use standard deviation as a measure of risk. And I'm going to come to why. But just as a first look, small stocks are about twice as risky compared to uh, what you want to call large stocks. Yes, they have higher risk premium, higher, higher risk premium. I mean, assuming treasuries earn during that time span 4%, the so-called risk premium or spread on small stocks is 12%, and the same number is about 7% on using only the APRs, is about 7% on large stocks. So yes, uh, risk premiums are quite high, but so are the risks. So if you think about it on a per, uh, so I think I'm going to do the following. I'm going to also calculate the average return to the average portfolio. Okay. So I'm going to take out, I'm not even going to do that. Let's not worry about it. Let's talk about return per risk. And I put that on quotes on purpose because technically I need to calculate risk premium, but I haven't brought in the risk-free interest rate data yet, which I will. Then we'll make a correction on that. But all I'm going to do is I'm going to take uh, the APR average return and divide that by what you want to call standard deviation. Oh, I didn't want to make this that's big. So we could actually see the whole thing on our screen. Yeah, APR is simple. The average return times 12. That's it in this case. I mean, it goes with the table one totals, whatever, but you know what it does. It's just the average return times 12. In this case, I made it 0.12 because technically speaking, those returns are already multiplied by 100 to get a percent number. People, as a rule, do not like decimals. All right. Now we have a little bit better picture. This ratio, even though I haven't properly calculated it because I should do it using risk premiums, it shows that this ratio is known as the Sharpe ratio. Okay, SHRPE, named after I think his first name was Jack, if I'm not mistaken. He's one of the giants of early financial theory back in '60s. Those guys had it easy. There was nothing done, so even simplest crap they did, they published in top journals because that's par for the course for all science. These days, what Newton did, we basically teach it, and we can teach it to eighth graders if they are gifted students. But during Newton's time, he actually had to invent calculus in order to make some of his calculations. So on a risk-adjusted basis, assuming this is proper way of adjusting for risk, actually there's a reason why those small cap stocks are yielding better. You can also put these things to a chart together. Do you guys know how to do a two-scale chart? Sometimes you want to put a chart of two things, but they're widely different in scales. So let me do a chart, just these. Insert, chart, and I'm gonna just do a line, okay? Get the dots on it. And by default, it puts it into this sheet, but I always like my charts to go to somewhere else. So I'm gonna right click, move chart to a new sheet, and I'm gonna call this size-based return and Sharpe ratio. You can you can have only up to 31 characters in any sheet or chart name, so it'll be economical on those.